All right, well, thank you very much, and thanks to the organizers for putting this together. I was reflecting on yesterday's presentations, and I just thought, it's relevant to my talk here as well. I begin by saying I'm filled with admiration for Kati Borner's continuing and clear devotion to modeling and visualizing research, impressed by Laszlo Barabasi's deep analysis of how the mysterious Q factor influences impact, charmed by Brian Uzzi's inspiring and thoughtful exploration of mentoring, reassured by Wendy Martinez's deconstruction of employment predictions, invigorated by John Lombardi's evidence-based commentary on the future of universities, provoked by David Krakauer's comparisons of constitutions, and engaged by Bill Rouse's model of university evolution. So I hope I can build on these, and the other talks were all very good. And so that's where I come to in starting this talk. So if you're tweeting, that's my handle. But this is focusing on human-centered models. The idea that if we had more than 100 data sets, we'd still predict everything better yeah, we would do better with more data sets, but some of the things are human-centered and therefore much more complex processes. And the goal that I'm after is more than papers or patents. The twin win suggests a societal transformation aspect, that we're doing more than just science and technology, and design is what I'll encompass, but I think all of those are directed, and I think we're all here because we believe that the work we're going to do is going to produce positive benefits. And so that's where it goes to. And this stems from my work on the book, The New ABCs of Research, which is intended as a guidebook for junior researchers about how to make their research more valuable. But it's also a manifesto for change. So it calls on the senior researchers, the academic administrators, business leaders, and funding agencies to actually change the way they work. Okay? And there's a systematic set of things that I want them to do. In fact, I'm now just finishing. If you want, I'll send you the draft of a guidebook for, it's called Rock the Research, about how to change your campus. It's about 35 items. It turns out to be campus culture change is not an easy thing. Bill Rouse made clear. But having a model maybe helps convince some people, but the actual process of change that goes bottom up and top down I found to be much more complex. So in searching for the ways, the levers, or the opportunities, or the things that I could do to produce change so as to make research have higher value, so as to attain the twin win of breakthrough theories and published papers and validated solutions ready for implementation. I think that's what we're all after. So Bill's talk actually gave us a model. It was a visual model with 4 stages. And I was, paying attention to the other talks about where is the model, in the sense of a model, a visual model, or a way where there were levers that I could operate on. Where could I push here to get more of that? That's what, this says, not just more dollars here, but a change of policy here produces an outcome that's more of what I want. So here's the pitch for the process model. It begins with 3 foundational beliefs that there are immense challenges out there, and these are, you can take your favorite list of these, some of them have been mentioned already, but these challenges are things like healthcare delivery, of energy sustainability, of community safety, of environmental preservation. I think that's what we're after, not just papers or patents. And so if we lay out that the problems of today are vastly different, and by and large, they're characterized by being socio-technical in nature. And therefore, the challenge and methods of research will need to grow beyond just the scientific method and beyond just the engineering method, but design thinking is, to me, an important part that we expand our notion of what research is about. The good news is that even though we have these immense challenges, we have immense powers, and with immense power, with great powers comes great responsibility. Remember Spider-Man? Actually, it was Uncle Ben who made that. That's a sort of favorite of mine. And so, the internet, World Wide Web, and social media do provide us unusual capacities to do our work, to collaborate, to build communities, and so on. The third is the raised ambitions that I see among the young people around us, and that's great, and the raised ambition of my colleagues, but also the raised expectation of funding agencies. So those are the sort of three foundational things of this model. These are places where things have changed, and that means the universities have to change, okay? So then I began looking for the guiding principles. There's two for this book. The first is the title, The ABCs, Applied and Basic Combined. And the idea was to overturn the Vannevar-Bush model of 1945 in Science, the Endless Frontier, where he said, he proposed the linear model of starting with basic research and then going to applied. And that basically has been shown doesn't really work. There are a half dozen substantive commentators along the way. Maybe the most notable is Donald Stokes, Pasteur's Quadrant, and a variety of others who have made clear that just rarely works. Even though Vannevar-Bush said it was inevitable that basic research would lead, it's just not true. And so the idea that you get higher value if you work on a real problem while taking a theoretical approach, and that you go for the twin win of a new theory, a breakthrough theory, and a validated solution. That's what we should be doing. So we want to raise the expectations of what people do. It's no longer this or that, it's this and that, and we can do both, okay? That's the premise of the book, or one of them. The second is that we need to expand our notion of research from just science and just the scientific method to looking at the engineering method and then design thinking. We could go into longer discussion of design thinking, but I think these are three very different methods that we should be teaching our students. So as I made this proposal to myself, I began to look for evidence that this was an important blend. And so I used the Google Ngram viewer to look at the 20 million books published in English over the last hundreds of years. And here you can see, I hope you can see, from 1900 to 2000, these are the frequency of occurrences of these words: engineering, science, and design. And there's a remarkable thing here, is that the word design takes off and by 1975 crosses over and becomes the dominant term. I was unaware of this, and it was a rather startling thing. It was not the fact that Steve Jobs and Johnny Ive made this happen, but they were part of that movement, and that we need to be aware that we need to shift the teaching in our university to focus on design. So that was encouraging, but I didn't feel like betting the book on one data point or one data set. And then I got access to the New York Times Chronicle database of all papers on the New York Times, or articles, and found more or less the same result, that engineer and scientists wiggle along, but in 1975, designer becomes the dominant talk. So these are both in the book and helped me gain some confidence that design thinking and design methods were important as part of our teaching. So here's where we are now in this kind of process model. And the book, I won't go in, has 5 things that you need to do to institute these changes. And they start critically with choosing the right problem. Now, I looked very hard on the literature of choosing what problems should be done. There's very little discussion of what kind of problems young researchers or even seniors should choose. Peter Medawar famously wrote that don't choose piffling problems. And this is repeated by many, and piffling problems is a cute idea. He's just saying work on significant problems, but he doesn't tell us how to find them or what they are and so on. So the grand challenges and the other challenges are a good starting place to immerse yourself in it. But of course, no research is going to solve cancer or, make clean water. All that we can do, all that we should do, and all we can expect is that each of us contributes a tile to the mosaic of understanding and improvement. We should be pushing ahead. We should expect our students, we should expect our colleagues to actually work on those things. There's a variety of other things, but the goal is the twin win of theories and solutions. We should be going after both of them, not just one of them. That's the premise of the book, okay? Maybe I should take a breath. Any questions here? Challenges to this? All right, I'll move on. You can come back to that. So, but there's another model that in the book that as I began to think about how to put this in place, how to make the changes in the university structure that I wanted, I began to realize I needed a theory, a model, an ecosystem for what is research about. And so it begins with this. This is in the latter part of the book, and it's closer to what Bill was saying. Universities contain departments. Departments hire and reward faculty who teach students, and the students join the faculty to form research teams. Okay, that's kind of a very simple model. And then it got extended that those research teams do something. They produce papers. That's, what we said, or they produce patents. They publish at journals and conferences with professional societies, commercial publishers, and there were businesses and governments, agencies, and I thought the role of journalists. Of course, this is frightfully simple. It's missing many things, many key things like state legislatures and their influence on these things, philanthropic donors, the role of patents, the role of technology licensing, and there's many, many other things you could add to it, and I kept it at this, and that's what's in the book, imperfect though it is. But in the last 2 years, I began to focus on one piece of this and came to realize that it was a much more dominant force than I had realized in making successful research teams. And just, it's quite simple that the relationship with businesses I began to understand was critical, and the collaboration with research teams turned out to be a high payoff opportunity, or so I thought. And I was encouraged by Yuri Leskovich. Lada Damek mentioned this wonderful guy. He's really quite brilliant. And when he was chair of the KDD, Knowledge Discovery and Data Mining Conference, he had analyzed the more than 1,000 papers submitted and found a wonderful, tantalizing little result, which was sort of a gift to me while I was writing this book. And it was that the papers that were co-authored by academics and business or government people had statistically significantly higher ratings than the papers by just academics. That was pretty powerful, and it wound up in the book, but it's, people who I've mentioned that to, say, it's just one little data point, we're not really sure, we are hard to trust it. So I became engaged in looking for that, for further evidence, and one way of collecting evidence, we go back to the citation count game, imperfect though it is. This is the paper mountain as characterized by this article in Nature, and you should remember that 44% of all the published papers, peer-reviewed papers and published sources, this is out of 57 million, 44% get no citations ever. Remember that. Okay, 32% get 1 to 9 citations. Now, I know for everybody in this room, your papers are on the upper 20%, and some of them get a huge number. 3 papers got more than 100,000 citations, and that's kind of interesting to study it. But there's lots of good work in the top, the top million papers. So, okay, so citation counts are interesting, and remember, on average, you're going to get very low numbers of citation counts. So I began to work with Scopus. Brad Fenwick, vice president of Elsevier, heard my talk, and he said, yep, I'm with you, I believe it, I've got the data. And we began to work together. And so we started, and this is a simple case, and just in the last couple of months, I now have, here's the data I want to show you about the University of Maryland. If you have a single author paper from a University of Maryland faculty, on average, you're going to get 3.0 citations. If you have collaborators on campus, if you work with others, you go up to 6.1. That's pretty good, double if you have a collaborator. Teamwork works. If you have collaborators outside the campus but in the US, you get up to 9.2. And if you get international collaborators, up to 13.9. But whoa! If you work with corporate or government, World Bank is a corporate, in this listing, the data is very complicated to analyze, but I think I can give you this distillation. Again, remind you this is just University of Maryland, but I was looking for numbers to show to my VP research and for my colleagues. 6 out of the 8 colleagues I showed to thought this was really great, this was actionable, this is something they could use to influence their colleagues. 2 had doubts about it, skeptical reasons, and we're continuing to investigate that. So there are vast differences across the disciplines in University of Maryland, and there are differences elsewhere. But as I worked more closely with Elsevier, Brad Fenwick put me in touch with a wonderful young researcher there named Ashek Rahman, who was also on the track of this. And, there was one more summary here. Just overall, if you work with corporate partners, you double more or less the citation, on average, again. Okay, so here's what Ashek Rahman has been showing, and this was at a National Academies presentation about 2 months ago. And here he shows, this is for University of Sheffield, Illinois, Minnesota, and Copenhagen, a sort of randomly chosen set, but you get the same pattern, that if you move up from, these are institutional collaborations, these are national, these are international, and business collaborations. So you get a pretty strong signal there. So then I began to work with Ashek Rahman, and here's a few more that I gave of universities I was interested in looking at as comparisons. And pretty much the ones I chose here do show that where the level of corporate benefit was at least twice as much as other collaborations. And so these are pretty strong results. I was surprised, and I have yet to dig into why Yale had such a strong advantage. I wouldn't have expected that. You have other universities we've looked at which have strong encouragement for corporate collaborations, UCLA and Stanford, which show up similar principles. And so we're continuing to explore. There's, again, I repeat, vast differences across disciplines. And we began to dive down into this. So I took the University of Maryland data, and I went for my first set was the computer science faculty, and I got the faculty who had the most such papers. The leading one had 22 corporate co-authored papers in the last 5 years, and he was what I thought was our deepest theoretician. Works on game theory and so on. And, you know, so we started doing the interviews, and he tells me, oh yeah, of course I work with industry because that's where the good problems come from, okay? And he described how he sends his students on internship, he invites corporate speakers to campus, and he builds a relationship over time. And the second was a vision researcher, also prominent, had 12 such papers in the last 5 years, and he said quite the same thing. I send my students for internship, I bring the corporate speakers to the campus, okay? So, we now have to get to questions because I'm all about actionable. I want to do more than understand. I want to know how to intervene and get something done. So why does collaboration improve research? It's a legitimate question. There's reason to believe it doesn't. Okay? There's reason to believe that the overhead of discussing things with other people wastes your time and that there's battles and confusions. And in fact, Sarah Kiesler long ago showed that collaborations often fail. Okay? So, you know, we should have this question, what's your theory about how collaboration improves research? So Brad Fenwick tells me, he says, top scientists seek out top scientists. It was kind of a strong statement. Even internationally, sometimes to get special resources. Okay, so sometimes you can understand for astronomy, you need to use a certain, or in physics, you need to use a certain piece of equipment. Okay, but if you read the book Enhancing the Effectiveness of Team Science, I strongly recommend. It's probably one of the best books in the National Academy of Sciences Press. Came out 2 years ago. It's their top download. Enhancing the Effectiveness of Team Science. Well-written, well-documented thing. So teams bring multiple perspectives and skills. Multiple perspectives and skills. Teams force clarification of goals. Because you have to work with others, you have to say, here's what we're going to do, here's the schedule, and so on. And then there's a certain way that cooperative and competitive energy promotes better work. Each member of the team wants to show off, wants to make their influence felt. They want to critique others. And if you manage that right, it's a good thing. I have a 30-year collaboration with Catherine Plaisant, a dear collaborator. Our discussions and our group meetings with students are not quiet events. We strongly disagree. But when Catherine disagrees with me, I pay attention, because I know she's got something to say, and she's very good. We've come to respect each other, so our critiques are given in a gentle and positive way. You may notice I did not include the word interdisciplinary here. And while there's huge pressure and interest in interdisciplinary, the evidence that interdisciplinarity on itself helps is very weak and even counterproductive. I had a whole chapter in the book about interdisciplinarity, and I threw it out. It became a section under teamwork. So I could go deeper about why interdisciplinarity is not the right flag to follow, but intersectoral work is a better one. Working, the key thing I want to leave you with, I mean, my goal for this talk is not just to show you what I've done, but to get you to change your behavior when you go back to your venue. So that's a little higher goal I've set, just as Bill Rouse was wanting you to do some homework. I hope in my presentation I'm successful, I'd say, if I get you to change what you do and what your colleagues and what your campus does. But there's more. But wait, there's more. Right, teams do publish more papers. They speak more often about their work to different audiences, and they cite their work more often. That helps marginally. I mean, the self-citations are about 10 or 15% of the literature, but even removing them, the effect and the benefits of teamwork, Brian, your 2007 work with Ben Jones and Wukti, just still classic resonance for me. They really tell the story in a solid way. And within that, there's really a powerful result which says that actually teamwork is more effective now than it was 50 years ago. The payoff of teamwork was there 50 years ago, but it's twice as much as it is now, and I conjecture because the internet enables teamwork to be much more effective and fluid. And so the capacity and the fluency with collaborative methods is greater. So that's a pretty startling, within your data, it does show that teamwork is actually more effective than it used to be, okay? Then readers, I believe, value multi-author papers more when they see multiple authors, especially if there's a prominent author among them, they will pay more attention to it, or there's evidence. These are all conjectures that need to be explored, but that's an argument about why collaboration works. But why does business collaboration improve research? That's kind of and business to be construed as businesses, government agencies, and NGOs, working on a real problem. And I would say, I will generalize it that another virtuous inside the university approach is working with other faculty who have a problem. So our work on visualization, it was advanced by working with biologists who had a problem, with economists, with sociologists, and even English literature people. And all of those and others resulted in papers in the visualization world because we were challenged by work in another discipline. So there, the interdisciplinarity helped, but I would consider it the bridging of a theory or a method with a problem. And so that's the kind of collaboration. In fact, I'm quite, let's say, encouraged that the National Science Foundation is beginning to move down that road. I've spoken there, and I've gotten a warm reception for this idea. And you may know the Algorithms in the Field program, AITF, which is meant for theoreticians, but it says they want proposals from a team of theoretician plus a domain expert with a real problem. And that's getting to be where I think the action is, okay? So you can take a look at that in the 6 NSF programs that I found that are in this. So why would collaboration like that be virtuous or helpful? First, I think you get better problems. That academics are smart people, but they're not always good in choosing the right problems. And by working with someone who has a real problem that people care about, that's meaningful, that has ways of validation, you start higher on the pyramid. So that's a good thing, to have a real problem, not an imagined problem that you work on in your lab, and as Daniel Sarowitz characterized in his powerful article called Saving Science, that he thinks science has gone off the track because it's worked on esoteric theories or problems that were not tied to the real world. And maybe that's why state legislatures have reduced their funding of state universities, because they just don't see that the problems they're working on have value. And if the state universities did more to support the goals of the state, they might get more state funding. And that would be one conjecture for your model there. So you get more resources when you work in industry. When we started working on Spotfire, it was just myself and a few students, but once it became a company, it grew to 200 people. I could never have 200 people working on tools like Spotfire. And so you get more resources to do it because it's seen as an important problem. There's also the virtue of time pressure. I know we all want the unfettered chance to explore and the long duration, which is good for some things, and Stephen Johnson wonderfully talks about how slow hunches are the way new ideas emerge. And slowness can be good, but the pressure can also be good. You get potent feedback about whether things work or not. I think Google, in its hybrid model of research, Al Spector's and Peter Norvig's description of their research methods, they call the hybrid method, talks about bringing theoretical computer scientists, putting them to work, writing code, shipping in 6 weeks, and then refining and refining and refining. And having that potent feedback from actually working at scale on real data, I believe, is another powerful virtue. Then, of course, there's a large payoffs of success, which have many cascading benefits to these ventures. So that's my conjectures about why business collaboration is payoffs. So if I'm taking my advice sheet back to my colleagues, and I hope you'll take it back to yours, how do we raise the research impact of our work? Well, already I think you've got the message. Form teams by working with problem owners. Okay? Form teams with good problem owners, owners who are potential co-authors, people who are smart, who understand what you're doing, who want to work with you. Ensure diverse team membership. Novices and experts, junior and senior, men and women, different skill sets, and a happy team of people who like to work together. The collaboration ready, but maybe also the collaboration enthusiastic team members. Sarah Kiesler, Nasher Contractor's work does show that people who have previous histories of working on successful collaborations are more likely to produce successful collaborations. It's maybe an expected result, but it's one that you should remember. And we do run into people who don't want to work in teams. And computer science is filled with those kind of people who are the loners, and getting them to work in teams is another challenge. Learn team management techniques. It's not that simple, especially as team sizes grow larger. There are skills you need to acquire and management techniques about how to manage teams. The book about enhancing the effectiveness of team science makes a distinction between the 2 to 10 person team, and I think they're right about this. 2 to 10 person team, I know how to manage. I don't know how to manage the 100 person team. I don't think I would be good at that because I'm tuned to the personal and working with small groups of individuals. So that's important. And then, coming from the interviews we've done, and I should say I've done them with computer science faculty, my colleague Linda Alduri has done it in arts and humanities faculty. And they say quite the same things. Building long-term relationships with professionals in business and government research labs, that's what they see, and that's the evidence of what the papers they've published come from. Second, seeking funding to work on problems that business and government find relevant. So here is an interesting subtle point, that from our data of University of Maryland, that the funding that comes from businesses did not lead to a lot of high-profile research results. It's kind of a surprise and a little disappointment. However, government funding, like DARPA or others, that actually supported universities to work with industry somehow did have a stronger impact. So that's kind of an interesting message that needs to be explored a little bit further. And then, a couple of my colleagues who were strong funding gatherers, they made the point that they would only work on projects that were funded at a substantial level, and often that required some government agency, some ERC, or one of the advanced manufacturing groups. I think those are good models. I think the NSF's efforts to build these center approach does really have value, that brings together 20 universities and 20 companies and government agencies and a pile of money, that, and the management skills to carry that off, that seems to be a virtuous approach. At the same time, you want to do pilot studies of little things that work on new ideas. I think that's right. Encourage your students to do internships at business and government labs. Okay, so that's another important part. Some of you may come from cultures where there's still a sort of antipathy to working with business and seeing that as less. There are challenges, there are problems, there are dangers of working with businesses. You want to find the right partners. You want to cultivate them to work with you in a way that's appropriate. And I could go on at length. The book has some of it, but there's a lot more lessons. So I'm out to try to make this culture change happen. And there's a group that's now met 4 times called, given its name, High Bar. High bar, highly integrative, basic, and responsive research. A little bit heavy-handed on the words, but a good, nevertheless gets the good idea. We recently met at University of British Columbia in Vancouver, and the goals, as it says for now, explaining the value of high bar research, facilitating success, and influencing grant allocation, promotion, and tenure. We have support from the Association for Public and Land-Grant Universities that addressed it at its recent conference. They host our website, and the National Academy of Sciences GWIR, Government University Industry Research Roundtable. Dan Sarowitz and I did 2 workshops in May and June for groups there, and that's helping to propagate it. This is a long-term effort. I don't expect this to change all of a sudden, but I hope you will contribute to making these changes possible at your universities. The examples of universities that have changed their tenure and promotion policies give us hope. The funding agencies that are beginning to put more of the emphasis on these ideas is also value. And of course, our hope is that all this brings the positive societal change we are seeking. So that's the summary. These are my models. They're crude. They're limited, but nevertheless, they gave me a way to think about the problems in a fresh way, and I hope they'll be useful to you. And that's it. Come join us at the University of Maryland for our next 35th annual symposium of the Human-Computer Interaction Lab on May 24th. So thank you for your time and attention.